This equation involves a square root right here. The way we solve this is isolate the square root, so let's add x to each side. So we'll get the square root of x plus 4 equals, and I'm going to add that x to both sides, get x minus 2. And now I'm going to undo this square root by squaring both sides. So I'm going to indicate that like that. I'm going to say it symbolically. I'm going to take the square root of x plus 4 and square it, but then I have to square the right side also. And now on the left side, when we square the square root, the radical comes off. That's why we do it. And we get x plus 4 equals, let's be careful here. Let's run our pattern. We'll square the first, multiply these two together. Positive times negative is negative 2x, but we double that. So this is minus 4x, and then square the last. So negative 2 squared is plus 4, right? Let's just do it again. Square the first, multiply these two together, negative 2x, double it, negative 4x, and then square the last, getting plus 4. Now this looks quadratic, so let's get everything on, say, the right side, 0 on the left side, and then try to factor it. So we will get 0 equals x squared. Now let's subtract this x, so negative 4x minus an x minus 5x, and then, well, look at this. We've got a 4, and then we're going to subtract 4, so we've got that. Now let's factor. So we'll get 0 equals, we can take out an x, and then we're left with x minus 5, from which we will get these two potential solutions. We'll get x equals 0 and 5. Now, these two numbers here, these are just potential solutions, because when we raise both sides of an equation to an even power, we have to check for what are called extraneous solutions. So we need to actually check both of these numbers to make sure they work back here in the original equation. So let's check. So here's how we're going to do this. This is an if-then. So I'm going to say if x equals 0, then, okay, so if, then, now let's put this 0 back up here in the original equation. We will get, doing so will give us square root of 0 plus 4 minus 0 equals negative 2. This will give us the square root of 4 equals negative 2, but the square root of 4 is 2. That is not equal to negative 2, so x equals 0 does not work. Now, let's say what happens here if x equals the other number, 5, then we'll put that 5 back into the original equation. So let's put this 5 back up here in the original equation, and that'll give us 5 plus 4 minus 5 equals negative 2. Right, see what happened here? I put that 5 back into x here and into x here. So this will give us the square root of 9 minus 5 equals negative 2. Square root of 9 is 3 minus 5 equals negative 2. 3 minus 5 is negative 2 equals negative 2. This one checks. So now, and it just turns out, we don't have to write this, but it turns out that 0 is what we call an extraneous solution. So in this equation, we've got this square root equaling a negative number. Now, we're not going to have to do much work on here because we know something. We know that when you use this symbol here, right, when you use this symbol, that radical sign, every real number has two square roots, one positive, one negative. When you use this symbol, you're indicating the positive one. So when we use that symbol, this side here is positive, equal, now this side over here, the right side, that's negative. So this is negative. So what we're saying is that a positive number equals a negative number. That cannot happen. So we can just write right away, no solution. There's no positive number that is equal to a negative number. So we're done. Now, you just might be curious what would happen if we did not see that and we just carried on about our business and we did something like this, what if we square both sides? We'll take the square, we'll take square root of 3x plus 1, square it, and then we'll square that negative 2. This will give us 3x plus 1 equals 4. Let's subtract this 1, so we'll get 3x equals 3. That'll give us x equals 1 as a potential solution. But now we have to check, right? So if we put that 1 back up into the original equation, let's see what happens. So we're going to check. And we do that by saying if x equals 1, then, right, it's always an if-then, then putting that 1 back up in the original, we'll get 3 times 1 plus 1, right? I took that 1 and I put it all the way back up here in the original. 3 times 1 plus 1, and that's equal to negative 2. So this will give us 3 times 1 is 3. This will give us 4 equals negative 2. Square root of 4 over here on the left side is 2 equals negative 2. False. So 1 doesn't work, but so we have to toss it out, but there's nothing else to go to, so now we'll just say no solution.